whatever makes that denominator 0 is what we need to look at. What other function do we need to worry about when it comes to domain besides a fraction, a rational function? What other type of equation do we need to worry about when you have a domain of an equation? Sabrina?
Square roots.
Yeah, the square roots or an even root, because what has to happen with it?
You can't ever divide by a negative number by itself.
Right, so we can't take the root of a negative number. So fractions make a restriction on domain. Square roots have a restriction on domain. The square root has to be positive, greater than or equal to 0. So in this case, if we have f of x, the x cannot be 0. Never works. So if x can't be 0, and we just have 1 over x, Brandon, what would the domain then be of 1 over x?
Negative infinity to 0, the loop thing, 0 to infinity.
Good. And parentheses around all of those because it's going to literally go right up to 0, hop over it, start right after 0, and then go to positive infinity. So they get parentheses. Going underneath and looking at letter C, talking about just the domain. Chelsea, how about the domain for g of x?
It can't be positive 2, so it would be negative infinity to positive 2 with parentheses and then 2 to positive.
Good. So again, when you have a fraction, whatever makes the denominator 0. There we go. That number would be in your domain with parentheses around it. That's the restriction on the variable. This second question wants us to find the range. So to find the range, in most cases, you'll probably want to look up the graph in the calculator and see what it looks like. Remember, when you're plugging in a fraction, if there's a quantity in the fraction's numerator or denominator, you want to make sure you're placing parentheses around that quantity. Some of them you might be able to reason yourself through why the range would be what it is. The range are the y values, your output values. But sometimes it's just a little easier to look at it as a graph and think, what is the range going from the bottom to the top of the graph? And if you put this in your calculator, you should see that it's in the first and the third quadrants, looking something like this. If you're not sure what the range is, use the trace function, use the table function, but just kind of in the table, go to where x is really big or x is really small. You should see it gradually getting closer to a number. So Grace, what do you have for the range of f of x? So she said negative infinity to infinity, and I agree almost. Right, it's going to be negative infinity to 0, and then 0 to infinity. So there are two pieces. Those two pieces are not connected together. They're separate. They never touch 0. They get really close to it. And that's because you have a fraction of 1 over x, and that fraction can never become 0. There's no way to make it 0 because there's a 1 on top. No matter what you divide by, that number will never become the value of 0. So you could take 1 divided by 1,000 and it's still not going to be 0. It's going to be really close to it. But it will never be the value of 0 because there's a 1 on the top, a number on the top. There could be a 7 on the top, a 100 on the top, a 15 on the top. But if you have a number divided by a variable, there's no way that can become 0. The second one for letter D, we have the range of g of x. So Michael, what do you have for the range of g of x?
I have negative infinity to 3 with parentheses, and so u, and then 3 to infinity.
Good, 3 to infinity. Again, kind of looking at that graph, it should have two curves similar to the 1 over x, but those two curves have kind of moved up the y-axis a little bit, and that place where they're kind of leveling off. So looking horizontally, there should be a place where they level off horizontally. So you go vertically from the bottom up to that spot, and then they're kind of just not really getting anywhere, but getting close to 3, but not really increasing beyond that. Any questions with those two? The range? Okay, so a little review of domain and range there. The other two questions underneath here are a review of the composite functions that we've been working with the last couple of days. So we have f of g of x, and really this is saying g of f of x. So, Kate, how do you work through this composite function?
You have to plug in g for x in the f of x.
And g is
3x minus 1 over x minus 2.
x minus 2. Okay, and he said plug that in for x in the f of x. And f of x says 1 divided by x, and instead of x, we have 3x minus 2, 3x minus 1, over x minus 2. So now I have a number divided by a fraction. And Eris, how do you divide by a fraction?
Reciprocal.
Yeah, you multiply by the reciprocal of the fraction that's in the denominator. So this fraction that's in the denominator is what we're taking the reciprocal of. But the number on top stays the same. In this case, it's just a 1. And then you're multiplying by the reciprocal of the denominator. You don't actually divide fractions, you multiply by the reciprocal. In any case, division actually is multiplying by the reciprocal. So this would become 1. If there was a 5 up there, it would be 5 times the reciprocal of the denominator, flipping it over. And then when you take 1 times anything, it stays the same. So x minus 2 over 3x minus 1. Bryn,
Did you pull this right out of our
it is letter E and F, but it's not A through D. The functions are the same of number 13, yeah. So instead of going to letter F, let's just look underneath to talk about the domain of this composite. So we want to find the domain of f of g of x. When you're finding the domain of a composite function, you need to find the domain of the inside function, whatever's inside, and make sure that overlaps with the domain of the answer. So you need to look with the inside function and the answer, and think about any restrictions that would be on that domain because of those values. So what can't x be? Instead of giving me the domain, think about what can't x be. Michael?
1/3 and 2.
Yeah, so it cannot be 1/3, and it also can't be 2. The 1/3 comes from your answer because the answer has a fraction and the denominator is an x. The 2 goes from the beginning, what you started with. That's what you plugged in. Because you are allowed to evaluate by plugging into the initial function and then taking that answer and plugging that in a second time. Or you can find the composite first and then evaluate it using the answer. So anytime there's a fraction, you need to look at that fraction that was plugged in for the composite and then the fraction that would make up your answer. So it cannot be 1/3 or 2. So just look at the fractions, the denominator of those fractions. So when you're writing your domain then, negative infinity to 1/3, 1/3 to 2, and then 2 to infinity. So if it can't be 2 numbers, think of that on a number line. It's everything but 1/3 and 2. It's allowed to be anything else. So the overlap would be the anything else, excluding those 2 numbers. And then the last one here, we have g of f of x. So Alice, that means we're doing what?
You're taking f and plugging it in.
And f is?
Just place it. 1 over x.
Yeah, 1 over x, yeah. Okay, so we're taking f and plugging it into g. And I have g written in parentheses over there. So g says 3 times x minus 1 over x minus 2. So we're taking f, which is 1 over x, plugging it into g. So we have 3 times 1 over x minus 1, divided by 1 over x minus 2. And if you take 3 times 1 over x, at least look at that part, what does that become? 3 times 1 over x. Alex? 3 over x. So now we have 3 over x minus 1, 1 over x minus 2. there are two different ways that you can think about simplifying this. And this is the hard part of this class. Because we didn't really go over common denominators thoroughly. We talked about it a little bit. We didn't talk about complex fractions at all, but you learned it last year. And I know you did because I remember teaching it. So
Please pardon this interruption.
in pre-calc,
Today's cross-country meet
when you
has
learn it
been
the previous
postponed.
year,
All
it's fair
students
game
should
for
return
any of
to
the
their
concepts that
ninth
we
period
go over.
class.
Alice, do
That's
you
all
remember?
cross-country students, all cross-country track runners, your meet has been postponed. Thank you.
So you could get a common denominator for the top and the bottom.
Correct.
So that common denominator would be x. So it'd be negative minus x over x. And that'd be over 1 minus 2x over x.
Okay, so just to kind of see what Alice did. The common denominator, if it's 3 over x, the common denominator is x. We have worked with fractions some throughout the last 5.5 weeks. So getting a common denominator, if we have 3x minus 1, there's an x in the one fraction, the second fraction needs an x in the denominator as well. So we multiply top and bottom by x, combining those together, 3 minus x over x. Same thing with the bottom. It happens to be the same common denominator, which is kind of nice. So there was 1 over x. That 2 is technically over 1. So now it's multiplying top and bottom by x. So 1 minus 2x, and then the common denominator is x. So Alice, the nice thing that happens with this is,
Well, the denominators sort of cancel out.
yeah, because the denominators are the same, they cancel out. And you're left with the 3 minus x, I'll write mine down below, divided by 1 minus 2x. And I think that's the hardest part of this class, is forcing yourself to remember how to do those things that we did last year, but then also applying it to the new stuff that you're learning this year. So 3 minus x over 1 minus 2x. Questions? Nice job, Alice. So the very last thing then, it says, what is the domain of g of f of x? This is equal to g of f of x. So when you're finding the domain, think, what did you plug into the problem, what function was substituted in, and what is your answer? And then the restrictions on those two pieces. So Virginia, how about some restrictions? Just talk about what can't x be. So instead of negative 1/2, how about positive 1/2? Because if you subtract the 1, divide by negative 2. And then there's another value that it cannot be. So if you go back up to what we inserted into the problem, what function got plugged into the equation? It can't be 0. So 1 over x was plugged into the problem. And that's the x that if we plug a 0 in, it will not work. So it cannot be 0. So 1/2 and 0 would be the restrictions. So whatever you inserted in, and then whatever the answer is. So for writing that as a domain, negative infinity to 0, 1/2, how about 0 to 1/2, and then 1/2 to infinity. Any questions with that? So as Brandon said, hey, isn't this a problem from your packet? Yes. Like these two are the last two problems of 13 in your review worksheet. So when you look at 13, you can kind of refer to this opener because E and F, I think, are D and E. I don't know. I think they're the last E and F or E and F. Oh, good. So E and F on this worksheet are E and F in your packet for number 13. When you're looking at any problem and it's a fraction, make sure that you have a restriction written next to it. Even if it's not in domain or range form, just say x can't be 1/3 and it can't be 2. So any fractional answer needs to have a restriction next to it. Even if it doesn't ask for one. I believe I made sure to say, identify the restriction on the test on Thursday. But make sure you are looking for that. So in the next, you got 10, 11 minutes. I want you to finish that first review worksheet, so you should have the front page done. And then And then you have the second page, the first page done, you've got the second page to complete. There's another review worksheet there in there as well. All the review worksheets, I would say 95% of the time, are always in your packet. And sometimes, I think in the next packet, I even ended up placing the answer sheets in there. This packet didn't get there, it must not have been quite on the ball. But I'm pretty sure chapter 2 has most of the answer sheets in the packet as well. That's why the packets are so thick, because they just have all the worksheets in there instead of like passing them out individually. I have an answer key to both those worksheets. You can come up and take a picture of them. The first one was sent for Remind yesterday. I'll send the second one through again today. Tomorrow I'll answer any questions from any of those worksheet problems that you have. So again, there are 2 worksheets, like a total of 6 pages for the chapter test. And then we're going to talk a little bit about completing the square tomorrow. Questions? So please work with the partner. Feel free to take a picture of the answer sheet. Again, I'll send it through Remind right after school that they're up here. Take a picture. Grab somebody to work with.